Hello everyone, welcome to this channel. Today we are going to see Introduction to Transaction Concept and Asset Properties in DBMS. Okay, so what is transaction in DBMS? We can define a transaction as a group of tasks in DBMS. Here, a single task refers to a minimum processing unit and we cannot divide it further. तो बेसिकली हम लोग ट्रांजैक्शंस को क्या बोलेंगे? What is transaction said to be as? A transaction is a unit of program that accesses and updates various data items of a database, right? That means what? It is a group of tasks, right? And here, a single task is nothing but a minimum processing unit, and that unit we cannot divide further. So this is what transaction, right? Here we are seeing one example where any worker transfers rupees 1000 from X accounts to Y account. यहाँ पे सिर्फ एक एग्जाम्पल लिया है कि 1000 rupees is to be transferred from X accounts to Y's account. Now, this looks simple, but it is having several low-level tasks involved in it. Let's see. This is the X account and this is the Y account. So basically, transferring 1000 rupees from X account to Y account. What all are the single tasks those need to be performed? So these are the single tasks that need to be performed when balance is to be transferred from one account to another account. Right. So your very first task is what? We need to open an account. Then here there will be the balance. Old bank balance, right? Then we need to subtract. That means what? 1000 rupees will be subtracted from the X account. The old bank balance minus 1000 will be your new bank balance. That will be added into the X account. Okay. And next we need to close bank account, right? Next, Y's account. Again we need to open the Y's account. Then we need to fetch what is the balance in Y's account. Then here, since 1000 rupees are coming in Y's account, that's why we are going to add, and this will be the new bank balance. Then this new bank balance will be given to Y's account and we need to close this account. So these are what? Transferring an amount from X account to Y account. There are several steps or single tasks those need to be performed. Okay. And this entire group of task is said to be as what? Transaction, since it is accessing and updating various data items of a database, right? Next, collection of operation that forms a single logical unit of work is called as transaction. A transaction accesses and updates various data items. After every transaction, the database should be in consistent state, okay? After every transaction, important thing is what? The database must be in consistent state. Okay. Recovery system is the main component of the transaction management or processing which deals with different failures. Okay. Number of transactions can be executed at the same time and they may be accessing the same database. Such concurrent access to the database may result in some inconsistent state of database. Concurrency control in transaction management preserves the consistency of database in case of concurrent access. Okay, this is what the simple introduction of the transaction. So here it is telling collection of operation that forms a single logical unit of work, right, is called a transaction. जैसे कि हमने previous example में देखा कि deducting the balance from account A, right, this is what a single logical unit. And this is what called as transaction, right? And here we see what transaction is definitely going to access and update various data items. After every transaction, the database must be in consistent state, right? We are going to see the asset properties. What is the meaning of consistent state in the coming videos, okay? And handling these transactions is the responsibility of the transaction management, okay? So basically, next we are going to see transaction concepts over here. If the database was in consistent state before a transaction, then on execution of transaction, the database will be in a consistent state. This is important thing, okay? पहले जो था consistent state में था आपका database, then after the execution of transaction, the database must remain in consistent state. In day-to-day life, a transaction can be defined as an act of giving something to a person and receiving something from the person in return. Example here we can take, if a customer wants to buy a product from a shopkeeper, the customer first pays an amount for that product and then receives the commodity from the shopkeeper in return. Here a customer cannot receive a product without paying amount. Similarly, after receiving an amount, the shopkeeper has to hand over the product to the customer. It means that omission of any step will result into invalid transaction. The simple and sweet, this is what the transaction concept, right? Now this is what the asset properties, okay, asset properties. So here, this is what atomicity, consistency, isolation and durability, okay? So this is what the meaning of asset, right? To ensure accuracy, completeness and the integrity of data, database system maintains following properties of transaction, okay? Let's see this one by one. Atomicity. It states that all operation of the transaction take place at once. If not, the transaction is aborted, right? There is no midway. That is, the transaction cannot occur partially. Each transaction is treated as one unit and either run to completion or is not executed at all. Atomicity involves the following two operations, abort or commit. Abort, if a transaction aborts, then all the changes made are not visible. Commit, if a transaction commits, then all the changes made are visible. Atomicity का simple meaning है या तो सब कुछ या कुछ नहीं, ठीक है, सब कुछ या कुछ नहीं. This is what the concept of atomicity. Complete it entirely or nothing to be executed, right? Example, let assume that the following transaction T consisting of T1 and T2. एक transaction है T, उसमें दो transactions है T1 and T2. A consists of rupees 600 and B consists of rupees 300. There are two accounts, A and B. A is having 600 rupees and B is having 300 rupees. Transfer rupees 100 from account A to account B, right? So these are what the instructions in this transaction. Read A minus B and write A. And here also read B, Y plus 100 and write B, right? Note, after completion of transaction, A consists of rupees 500 and B consists of rupees 400, right? A consists of rupees 500 and B consists of rupees 400. If a transaction T fails after the completion of transaction T1, but before completion of transaction T2, then the amount will be deducted from A but not added to B. This shows the inconsistent database state. In order to ensure correctness of database state, the transaction must be executed in entirely or the transaction must be aborted as no action took place. As no action took place, okay? That means what? Here in the previous slide, addition of A and B is what? 900, right? Addition of A and B is what? 900. So here, after completion of these two transactions successfully, again the addition of A and B is what? 900. 500 plus 400 is what? 900. That means what? Before and after, the database state is in consistent state, okay? But suppose here, as I'm telling you that, अगर यहाँ पे amount deduct होता है and the system fails over here, it is not added to this particular transaction, okay, or account B, then here the database will go into inconsistent state. That's why here we need to abort everything, right? So here, if a transaction aborts, then all the changes made are not visible. This is what the concept of atomicity. Next is what? Consistency, okay? The property of consistency states that the database must always remain in a consistent state after any transaction. Thus, a transaction must never have any damaging effect on the data and information that resides in the database. In case, before the execution of a transaction, the database happened to be in consistent state, then it has to remain consistent even after the transaction get executed. Previous example, I have said you that in the atomicity, that either to execute entirely or nothing is to be executed, right? Consistency, whatever the database was in consistent state, even after the transaction get executed, the database must remain into consistent state. For example, the total amount must be maintained before or after the transaction. In the previous example we have already taken, A is having what 600 and B is having what 300. The total amount is what 900. Total after T occurs, after the execution of transaction, it is 500, A is having 500 and B is having 400. Total is what 900. Note, therefore the database is consistent. In previous example, when T1 is completed but T2 fails, then inconsistency will occur, definitely. Okay? So this is what the concept of consistency. Next, isolation. This property ensures that for every pair of transactions, one transaction should start execution only when the other finish execution, to avoid interleaving of data into an inconsistent state. Okay, this is what the concept of isolation. This property is definitely going to ensure us that for every pair of transaction, one transaction should start execution only when the other finish execution, right? To avoid interleaving of data into an inconsistent state. So here you can see this is the example over here. Account A have rupees 400 and A want to transfer rupees 100 to account B and account C, right? This is what the account A, right? It is having balance as 400. It want to transfer 100 to account B and again to account A, right? Here both transactions run concurrently and reads 400 as the balance, right? दोनों ट्रांजैक्शन कंकरेंटली साइमल्टेनियसली शुरू हो गए अकाउंट ए, अकाउंट बी एंड अकाउंट सी, right? And both the transactions have read the value as 400, right? In that case, the final balance of A would be 300 instead of 200, which is wrong, right? If the transaction went run in isolation, then the second transaction would have read the correct balance as 300, right? So this is what the concept of isolation, which tells us that one transaction must start only if previous transaction have finished its execution, right? Then only the correct data will be read by both the transaction. Okay. Next is nothing but durability. This property ensures that once transaction completes successfully, all updates that is carried out on database should persist even if there is a system failure. We can assure this by ensuring that all logs have been written to disk before transaction completes, and data stored is sufficient enough to reconstruct the database after failure. The recovery subsystem of the DBMS has the responsibility of durability property, right? This is what the concept of durability, which is ensuring us that even after the system fails, then also we can persist our data, right? We can carry out various transactions even after the system fails. And to ensure this, various logs have been maintained into the disk before the completion of any transaction, okay? And there must be enough data to reconstruct the database after the failure. And who is responsible for this? The recovery subsystem of the DBMS is responsible for this durability property. Okay, thank you for watching this video.